All right, welcome to the Explainer. Today, we are taking an absolute trip. We're diving headfirst into some seriously mind-bending physics and math. We're talking about bridging that massive gap between microscopic quantum mechanics and the actual macroscopic shape of space-time itself. It's all centered around the holographic foundation of the Adelic Langlands Program. Basically, it's a framework that translates incredibly abstract topological statistics into the physical geometry of our universe. Let's get right into it. So, the core mystery we're tackling today is this. How do abstract, discrete numbers physically weave the continuous gravitational layout of our universe? I know, it sounds a bit like magic, right? But there is a totally rigorous microscopic engine driving the whole thing. We're going to break down exactly how these discrete, quantized rules scale up to literally bend space and time. Here's our roadmap for this explainer. 1. The holographic blueprint. 2. The microscopic engine. 3. Topological sculpting. 4. Crossing the quantum boundary. 5. Semiclassical shadows. And finally, 6. The mass gap. Let's kick things off with part 1, the holographic blueprint. Think of the framework developed by Xu and Wen as a sort of micro to macro translator. Down at the absolute microscopic level, you have these distinct, discrete statistical links. But when you bundle a massive number of them together, taking what physicists call the large N limit, they weave together to form a continuous classical reality. It's kind of like how thousands of individual threads weave together to form a perfectly smooth fabric. The Adelic Langlands Program is basically modeling how these microscopic field theories project outward into the macroscopic geometry we actually experience every day. All right, zooming all the way in now for part 2, the microscopic engine. These tiny gears churning at the quantum level are known as weakly local hopping operators. What they do is execute mathematical translations across this branching, root-like structure called a Bruhat Tits tree. And this tree acts as the explicit lattice mechanism of the entire system. Now, if you look at that higher cut product index, that dictates an anomalous phase shift, which basically means it prevents perfect commutationality at the microscale. But ultimately, these hopping operators are the true cogs in the machine, entirely defining the statistics of the system. Just to keep our footing here, let's quickly define the mathematical engine driving all this. It's called LOSA, or the local operator subalgebra. This is the exact microscopic mechanism that generates those weakly local hopping operators. It's literally the source code that locally deforms quantum excitations and provides those lattice translations we just talked about. Moving right along to part 3, topological sculpting. Here is where things start to take on real structural shape. Specifically, boundaries force a shape through a twisted Z-force secondary cocycle. Simply put, this acts as a hard boundary constraint. It breaks the conformal symmetry of the system, fractionalizes it, and forces a strictly quantized topological phase shift. It is literally carving out the fundamental rules of how different particle and string dimensions interact and twist around one another. And that carving process leads to a massive structural shift, governed by the D4-Postinikiv differential. We are looking at a serious transdimensional action right here. Energy is quite literally being dumped from zero-dimensional, localized point particles directly into one-dimensional string geometry. We're filtering energy across dimensions and breaking the standard boundaries of the representation. Let's trace that exact domino effect. Step 1, that D4 differential becomes active. Step 2, it triggers the Z4 anomaly twist we just looked at. Step 3, this generates a negative Futaki invariant, which, by the way, is a massive mathematical red flag for geometric instability. Step 4, because of that instability, the metric cusp collapses. And finally, step 5, non-tempered states are born. This is the universe physically reorganizing its own spectrum in real time. And amidst all this mind-bending, complex topology, an incredibly familiar number pops up, 1.618. Yeah, the golden ratio. When a very specific type of anomaly, a Fibonacci fusion category, governs the boundary, its quantum dimension is literally the golden ratio. This irrational number mathematically smears the boundary interface, completely changing how fields leak across different topological channels. It's honestly just amazing how this ancient, classical number shows up deep in the most advanced quantum frameworks. Let's push in to part 4, crossing the quantum boundary. This is that soft edge where quantum fuzziness meets the structured bulk of reality.
Imagine a classical geodesic hitting this boundary. You basically get one of two very different outcomes based on a specific boundary parameter. On one side, we have the subcritical lock. That's when the parameter is less than or equal to 1. The boundary basically acts like a brick wall, perfectly reflecting the trajectory back into the chaotic bulk. But on the flip side, if the anomaly pushes that parameter past 1, we get a phase horizon crossing. The trajectory actually breaches the threshold. It escapes the continuous bulk, gets captured by an isolated arithmetic cusp, and hops right onto an outlier rail.
But here's the catch. This transition isn't just on sharp, catastrophic snap. It is heavily governed by the Tracy-Woodham interface, which swaps out those sharp classical boundaries for fuzzy quantum zoom layers. It regularizes how things leak through using airy tails. And crucially, this fuzziness prevents the entire geometric system from completely breaking down. It smoothly converts those discrete steps into continuous p-adic distributions, acting as a massive analytic buffer.
All right, let's pull back and zoom out for part 5, semiclassical shadows.
This right here is the big visual payoff of this whole explainer. In a perfectly untwisted system, a geodesic path is going to travel perfectly straight. But the moment that path encounters the non-invertible string loop anomaly we've been discussing, it gets deflected, literally deflected by a quantized angular step of pi/2. The microscopic anomaly acts as a gravitational lens, physically bending a macroscopic spacetime trajectory. How wild is that?
So what's actually causing that bending? It's the Arakelov trace anomaly. When a geodesic crosses these anomalous interfaces, scale invariance is broken. The microscopic quantum fluctuations dynamically scale the effective proper mass of the trajectory. Basically, each of those defect loops acts as a local conformal sink. It warps the background metric and physically forces that deflection to happen.
Which brings us to our final stop, part 6, the mass gap. This is basically the universe's ultimate defense mechanism. Those discrete, finite quantum defects create a mass gap, which acts as an automated cutoff at the center of those concentric string loops. If this were an infinite system, the whole thing might collapse into classical scale invariance. But because it's finite, the mass gap topologically shields the continuous arithmetic manifold, protecting it from singularity collapse. It essentially guarantees the stability of the entire system.
To wrap up this incredible journey, I want to leave you with this summary quote. The non-invertible, non-pointed arithmetic data of the number field is perfectly unified with smooth, stable, and regularized semiclassical space-time trajectories. What that really means is that those incredibly deep, abstract, microscopic arithmetic rules are the exact same things dictating the macro-level stability and shape of our everyday reality. They are intimately physically connected.
So here's a final thought to chew on. If the completely discrete arithmetic data of numbers can physically weave the gravitational layout of our universe, what other mathematical ghosts are hiding in the fabric of our reality? Thank you so much for joining me for this explainer, and definitely keep questioning the universe around you.